Greetings, Yuma High School Geometry. Starting off chapter 3 with section 3.1 and getting a lot of vocab in here. You'll notice I have 28 slides and they'll go really quick, though a lot of them we're just going to rattle through them. Anyway, our objective is to identify relationships between figures in space, lines and planes, parallel, perpendicular, skew, that sort of thing. And then we will get into a bunch of vocab involving transversals and the relationship between the angles that are formed when two lines are cut by a transversal. So here we go. A lot of this is going to be review. Your job is to take notes if you don't know something and be ready for some homework tomorrow or the next day we have class. All right. Okay, here we go. Now, looking at these lines and planes, this is not a box, this is a bunch of planes going on forever. Lines, of course, going on forever, but we're representing them with the blue lines here. So consider these as lines and planes. Well, parallel lines, I'm sure you already know, are lines that are coplanar and do not intersect. This is the symbol that we're going to use to indicate parallel. All right? So, first of all, we look at this figure and we see AB, line AB, is parallel to line CD. It's also parallel to line EF and HG. All four of these lines in this diagram are parallel lines. And we write them like this, parallel lines. Okay, your turn. Which lines are parallel to BF and which are parallel to EH? Pause for a second if you want to try it on your own. I'll reveal the answers in a second. All right, here we go. Answers coming up. Parallel to BF, CG, AE, and DH, they're all parallel to one another. And to EH, parallel lines are AD, BC, and FG. All right. Now, skew lines, they'll never touch, but they're not in the same plane. All right? They're non-coplanar. They're not parallel. They are skew. For example, AB in green and EH never touch, but they aren't in the same plane. They are skew lines. And so our AB is skew to FG and to DH and to CG. Okay. Moving on. I hope that's clear. If not, you can replay it anytime. Okay, planes can also be parallel. For example, plane ABFE is parallel to DCGH. Go back to the original picture, parallel planes. Your turn. Which plane is parallel to ABCD and which is parallel to ADHE? Pause if you like. Here comes the answer. ABCD is parallel to the bottom one, EFGH, and ADHE looks like the front. It's parallel to BCGF. Okay, perpendicular lines. You know, they form 90-degree angles, and the symbol for perpendicular is that thing right there. So, if angle ADH is 90 degrees, then line AD is perpendicular to line DH, and that's how we would write it. Planes can be perpendicular as well. If ADH is a 90-degree angle, then plane ABCD is perpendicular to plane DCGH. Continuing on, we're going to get into transversals now. A transversal is a line that intersects two or more coplanar lines at distinct points. L and M are our two lines. T is our transversal. So lines L and M are crossed by this transversal, line T. Now, 8 angles are formed when we have one line, one transversal crossing two lines. And I've labeled them just for simplicity, 1, 2, 3, 4, 5, 6, 7, and 8. In our next nope, sorry, not ready for that yet. little more definition. The angles between L and M we call interior angles, and those are outside L and M are called exterior. So the interior is in the reddish, exterior is the yellowish. So you'll see angles 3, 4, 5, and 6 are interior angles. 1, 2, 7, and 8 are called exterior angles. Now, certain important characteristics crop up among these angle pairs formed when a transversal crosses two lines. So we give these pairs special names, and this is critically important. Two interior angles. So we're going to have four different sets of relationships here. The first is called alternate interior angles. Alternate means we got opposite sides of the transversal going on. So two interior angles on opposite sides of the transversal that aren't immediately next to each other are alternate interior angles. So 3 and 6 are opposite sides of the transversal and both interior. That is an alternate interior angle pair. So is 4 and 5. Okay, opposite sides of the transversal and interior, alternate interior angles. Okay, likewise, exterior angles that are on opposite sides of the transversal are called alternate exterior angles. 1 and 8 is one pair of alternate exterior angles, and 2 and 7 is a second pair of alternate exterior angles. Next, same side interior angles are interior angles that lie on the same side of the transversal, like 3 and 5 is one pair, and 4 and 6 is another pair of same side interior angles. And the last one, the fourth one, corresponding angles. They're on the same side of the transversal and in corresponding positions relative to their respective line. So 1 and 5, both being on the top left of their respective crosses there. 1 and 5 are corresponding, as are 2 and 6, 3 and 7, and 4 and 8. So we have four pair of corresponding angles formed by this configuration. 1, 5, 2, 6, 3, 7, 4, and 8. Now it's your turn. We may not always have the lines and transversals oriented like the examples I've given you. So I've crossed things up a little bit. Your turn to name two pairs of same side interiors, two pairs of alternates. Pause. I'll reveal in a moment. Here we go. The same side interior angles are 2 and 3, which make one pair of same side interiors. 6 and 7 make the other. The alternate exteriors, 1 and 8, 4 and 5. Which pairs are corresponding angles and which are alternate interior. Pause. And here we go. Corresponding, 1 and 3, both on the top left. 2 and 4, top right. 5 and 7, bottom left. 6 and 8, bottom right. And the alternate interior angle pairs, 2 and 7, 3 and 6. So, hope that gets you going. Hope you have some good notes. We'll be able to work on this in class. Write your summary. I'll be checking for them, and I'll see you soon.